Hi everybody, today we are going to learn about the possible type of questions and that would be in the exam 2 for the written part. So exam 2 would be very similar to exam 1 in terms of the written part and Excel part, except the time should be shorter. The reason is because the exam schedule for the final exams is starting from 5:30 to 10:30, so we wouldn't have it until midnight. That's one of the main important ones. The good news about the exam 2 is exam 2 is easier than exam 1 in terms of working on the Excel part of it. So let's see what we would have on the written part, what type of question we would have. Again, we would have only true, false, multiple choice type of question, and today we are going to review some of them. These are the true, false type of questions. And I'm having also the answer of this on the note part. If you download the written part, if you download the slides, you see in the note part of the slides the answer for this one. Let's go over this. A sample statistic is an unbiased point estimate of a population parameter if the mean of the population of all possible values of the sample statistic equals to the population parameter. So let me remind you that this is one of the important parts, that we were saying that a good sample, an unbiased sample, is a sample that the average of the samples would be equal to the average of the population. So therefore, this statement is true. Part 2, the second part, the standard deviation of all possible sample proportions increases as the sample size increases. So this part is false. Why? If we increase the sample size, the standard deviation should decrease. The central limit theorem states that as sample size increase, the population distribution more closely approximates normal distribution. If you remember, for the central limit theorem, we had a closer, by increasing the data set sample size, they would be more closer to the normal distribution. The sample standard deviation is an unbiased estimator of the population standard deviation sigma. Well, the sample wouldn't be unbiased exactly, so this is very strong term feeder. Therefore, this statement is false. Sampling error occurs because of incomplete information. That's true. When we don't have enough information, we will always have some error. The normal probability distribution is a discrete probability distribution. This is false because the normal probability distribution is always continuous probability distribution. The z-value tells us the number of standard deviation that a value exists from the average. So that is also true. If the random variable x is normally distributed, 68.26% of all possible observed value of x will be within 2 standard deviation. That's wrong because within 2 standard deviation, the percentages will be 95 point something, not the 68. This is another one. Question is long, but basically the most part of the thing that you need to read and answer to this question is in the last 3 sentences. So it's talking about the manager of the quality department, that they are having the products, they are making sure that products that they are measuring follow the normal distribution. They are taking the 800 pound per square inch as a sample, and then they take the statistic test, and they found that the p-value is 0.06 for each test, and the significant level for alpha is 0.10. And then they are saying that therefore the null hypothesis must be rejected. So before going through anything, remember that if the p-value is smaller than the significant value, we should reject the null hypothesis. If p-value is greater than the significant value, we should accept the null hypothesis. So now let's see. What's the p-value? 0.067. What is the significant value? 0.10. So p-value is smaller than the significant value. Therefore, we should reject the null hypothesis. Therefore, this statement is true. A type 1 error is rejecting a true null hypothesis. Remember, that's true. this definition of type 1 error. Type 1 error is rejecting a true null hypothesis, and type 2 error is accepting the false null hypothesis. So that's the main difference between these two. For a hypothesis test about a population proportion or mean, if the level of significance is less than the p-value, the null hypothesis is rejected. That's false. Why? Because it's reversed. If p-value is smaller than significant value, we should reject it. But if significant value is less than p-value, that means p-value is greater than significant value, right? Therefore, we should accept it. Therefore, this statement is wrong. When comparing two independent population means, if sample size number 1 is 13 and sample size number 2 is 10, degree of freedom for the T statistic is 22. Well, remember that, let me draw something here. Remember that the degree of freedom was the sample size minus 1. So sample size minus 1 for the sample size number 1 is 12. And then for sample size number 2, sample size 10 minus 1 is 9, right? Summation of these two is 21. Therefore, this statement is false. The F statistic can assume either a positive or negative. This is false. Remember, I said when we are measuring the F statistic, we should always check that it is always positive or having the absolute value of that. So positive or negative is wrong. We should always consider the positive. So this statement is false. A one-way analysis of variance is a method that allows us to estimate and compare the effect of several treatments on a response variable. So this is important, several treatments on the response variable. Remember that ANOVA, we had more than 2 groups. We have 3, 4, 5 groups to take the ANOVA analysis. That was the main difference between ANOVA and the t-test. Therefore, this statement is the definition of ANOVA and it's true. The dependent variable is the variable that is being described, predicted, or controlled. Yes, that's true. That's the definition of dependent variable. A simple linear regression model is an equation that describes the straight line relationship between dependent variable and independent variable. That is also true. Remember that regression line, if we have here x and here we have y, the regression line is a straight line. It's a linear. It's not like any weird shape, right? And shows the relationship between x and y. In testing the difference between the means of two normally distributed population, the average is 50. Sample size number 1 is 9. Sample size number 2 is 13. What's the degree of freedom? So degree of freedom is sample size number 1 minus 1, for degree of freedom of that is 8. And sample size number 2 minus 1 is 12. So summation of them is 20. If we are testing the difference between the means of two normal distributed independent population with sample size 10 and sample size number 2 is also 10, what is the degree of freedom? So 10 minus 1 is 9 plus 10 minus 9 is 1 is 9 as well. So degree of freedom for these two is 18. The variable of interest in an experiment is referred to as the categorical variable, regression variable, response variable, or factor variable. So variable of interest has 3 different names: response variable, dependent variable, or variable of interest. And independent variable is just independent variable or exponential variable. But variable of interest is a response variable. For the same test of observation on a specific dependent variable, two different independent variables were used to develop two separate simple linear regression models, and these are the results. Based on the results, tell us what you understand. So remember, when we are taking the ANOVA test or regression analysis, we are checking the R square, and if this R square is closer to 1, that means that model is better, or we should rely on that model more than the other one, right? So in order to rely the prediction of that model. So here we have two models, and it's telling that the prediction based on model 1 is better than prediction based on model 2. How we can say one model is better than the other? By checking the R square. R square of model 1 is greater than the R square of model 2, so therefore this is correct, right? The following results were obtained as part of a simple regression analysis. So the null hypothesis between the dependent variable and dependent variable should be rejected or accepted. So p-value is 0, 0, smaller than the significant value. Therefore, I should reject the null hypothesis, right? So that is all that we have. And these are the type of questions that you would have on the exam. If you have any questions, just let me know.